Well, since we're sort of going back to back this morning, I want to keep going, be mindful of the time. But let me just say I'm really impressed at the number of people here. And I think given that it's a beautiful day outside and there's lots of other places to be and lots of other things to do, you guys are true data nerds for sticking it out and wanting to hear me talk about production use cases. So give yourself a round of applause. Like, let's do that. Get energized. All right. So here's what I'm going to be talking about today. Two things, two cases. When putting things into production, and I'm putting this in quotes because I can relate, and I'm not blaming the data scientists, but why do data scientists take so long? And why does data science in production take so long? And then I'm going to be talking about two cases where we're going to be speeding up the ETL and creating insights at the same time. And another where we're going to start with a template and make analytics reusable. So all right, I hope you guys are excited, because I am. And just a quick break, a quick pause. We're talking about data science in production, and why are we focusing on this specifically? And I think there'll be a fair mix of audience. I've been told that there's business people, data scientists, analysts, people of all sort of places in the organization. But what we have to realize is that business lines are often the sponsors and need to see some kind of return from the projects. I mean, it's nice if you're a data scientist and you have a mandate to just go code ad infinitum, but there's somebody who's waiting to see something from that, usually. If you're not, you're in a great position, don't leave, just stay there. But importantly, what you do as a data scientist creates value across the organization and provides the teams that you work in, whether they're pure like data analytics teams or sort of mixed teams, with some of the recognition that you need to have a say in what happens. And when we're talking about data science in production, it can be everything from strategic insights to augmented or sort of automated decision making, where that's feeding what you're doing and what you're deciding on. So wait a minute. I know the program said you're going to be listening to Ken Sanford. And so I'm just putting up his picture because I don't know where he is. He disappeared on me last night. I came in at the last moment to sub him. So if someone sees him out in South Beach, just yell, "Hey, Ken! DataIku is looking for you back in the data salon." But anyway, the thing is, he had another thing to do, and it's because he's getting a little old. I mean, I say this with empathy because I feel him. And I mean this, this is a rather young space. Let me just see a quick show of hands of who's under 35 in this room. And I'm not asking the flip question. Oh, we actually have we have some veterans in this room. That's awesome. But Ken's away, which means I'm going to be doing this, and I'm Yashas. I'm the evangelizer in our alliances team in the US, where we work with basically consulting and technology partners. And my role is to kind of get them trained up and empowered. And just a little secret, and I have a confession to make at this point, I'm ABD. I don't know who knows what that means, but basically that's all but dissertation. Get just a few months out from the PhD if I can keep writing and doing other stuff at the same time. But the reason I say that is because I understand why data scientists take too long, right? They spend most of their time doing ETL. This is from a Crowdflower survey that they do every so now and then, which basically said, as a data scientist, what takes up most of your time? And it's doing this routine thing about collecting, labeling, organizing your data. And I can relate because I took several years to collect, acquire, and then clean my data. And I mean literally months and months of just doing that. And that's usual. And so as a social scientist, I have a few theories about why data scientists take so long. And these are just hypotheses, very hard to find causal inference type evidence for these things. But I have two. So one is that data scientists have a hard time getting their hands on good quality data, and so they must scrub away. And maybe some of you in the room relate to that, or maybe you understand that the data you have in most organizations, businesses or otherwise, is going to be not that clean in the first place. And then second, which is not a mutually exclusive hypothesis, is that given their background, which might be some kind of advanced degree program where they spent years looking at a screen and cleaning data and code. They're actually pretty good at cleaning and organizing data. Love writing functions to do all sorts of things. And so they focus on what they can do well and control. I mean, that seems likely. And the reason I say this is I have some evidence for both. So on the left, it's from the same Crowdflower survey. It just asked the data scientists, are you happy or very happy? And guess what? Like 88% of them were like, we're like happy or very happy. Because we're doing kind of what we like and love and what's not to like about that. But in the same survey, they also talked about being sort of hit by a data deluge. Like they just have way too much data and more than what they know to do with. And so that's my first thing about what people say about data scientists taking too long. And a little bit I'll speak to sort of why data science is hard to do in production. Right? Why getting from your prototype to actually productionizing things, putting things into production is hard, is because it's not just the same team that does those things. There might be a data science team or an analytics team, but once you put things into prototype, into production, you might be dealing with IT or DevOps. And that's just the world we're in, because there's a lack of established platforms and frameworks to do that. And particularly on the data science side or the data scientist side, there's an overall low maturity on deployment skills and experience, which means as McKinsey probably pulled this out from the air, but 10% of data science projects are deployed into production, which means the vast majority aren't, and that it takes an often long time. Which also means that if the data scientist is the unicorn that you can't find, a DevOps production-ready data scientist is a unicorn with a rainbow horn. Just never going to find them. And that's important because it means that getting data science to be a data product is difficult. I mean, a product could be anything. It could be a predictive model that scores things automatically. I mean, it's just something that kind of works on its own once you've gotten to the point of making it. Anyway, so I have some case studies where we kind of try to get around some of these things and try to do some of these things at DataIku, and I'm going to just go over them very briefly and actually leave a little time for questions, because I think that's going to be fun as well. So case study 1. Now that I've gotten you in the room, I'm going to tell you about regulatory compliance. Great, trapped you. And this case study actually comes out of France, where we have a rather large team as well, and it's called Anacredit, and the guys who work there have put together a few contextual slides, and the most important thing is basically that every financial institution must report a monthly data set of loans over 25K with up to 95 attributes. And the thing is, this sounds like a classic, where is all of this data? How am I going to find all of this data? Where, the list of the types of data and the frequency with which it must be reported makes it sound like a very boring ETL project. So just find, accumulate, accrue, and send this forward. And so we were brought in to do this with a few other partners, and we wanted to come up with an innovative solution for this. So what did we do? We decided to build and automate this financial reporting and make sure that it could be done in the same format across 8 countries. And we also wanted to make sure that this process accounted for the fact that there would have to be quality checks, there'd have to be reporting to an external regulator, as well as the ability to correct that as we go on. And more importantly, what we wanted to do was use this opportunity to provide broader reporting on data quality, but also insights on the portfolio. So kind of use this ETL play to actually do something different and do something a little more. So we got together with a few of our partners. We actively worked with PwC, which worked with the regulatory part and the understanding of the space and what was sort of necessary. And we also worked with one of our technology partners, which is Tableau. So what that meant was when we built a prototype, it looked something a little like this. And we focused on sort of getting a minimum viable product. We wanted to get something done. And so we worked with just 2 data engineers, a business analyst, a risk analyst. And the 2 data engineers might be kind of like a data scientist and a data engineer. So within 2 months, built this prototype that's agile, well documented, and reusable. And it runs at scale and, in the company's infrastructure that it has. And it's just articulated with this ETL and data ingestion tool that we have, or part of what the tool does. And so what we did was we gave a solution that has the ability to go pick out data from different sources. So we have the instrument data over there, the counterparty data, and even some of the open data that's out there on the counterparties. We can pull them all in together, and we can build this pipeline that kind of goes forward and processes these data and makes them deliverable in these XML templates. Pretty simple, but the thing is, once you build it, you can now run this on a monthly basis, make sure that you can do your ETL in this automated and easy way. And you do it once, and then you can not forget about it, but make sure you can automate it so you don't spend the same amount of energy doing it over and over again. What this means is it provides some of the insights we're talking about right away, because we can build these end-user dashboards through our own platform, but also export to Tableau. So this is some of the dashboards that they built just to do a few things. So data quality and compliance, but also sort of risk portfolio reporting and some simple insights. But more importantly, what it did was when we put together all of this data in the same place and in the same time, it gave us a great playground to do some ML. Because now we have all of this data together. And what you need to build good predictive models is just vast amounts of data. Probably the more, the better. And one of the things we did was we predicted late payments across the loan lifecycle, because we got the instrument data, the data on the counterparty, the data on the lifecycle of the loan itself. And we kind of provided a solution that took this ETL, boring project, reporting, financial reporting, so regulatory reporting on top of that, but made it possible that once the data came into the same place, we could start to do the ML bit at the same time and sort of provide an additional value to anybody who would want to use this solution. And we can do fun things like anomaly detection on the loans too. And that's something that is where this project is going next. So, all right, that was one. The next one is actually out from the US. So this is one of our customers here, where we had to build a real-time recommendation system at scale to power a sales platform that is at its maximum used by thousands of clients. And as a first sort of project to get them rolling, to get them a win easily, we wanted to do a project where they provided customized recommendations, 3 models for their clients. So, they're our client, but they have their own sort of clients. And the idea is that these would be real-time recommendations. And so just to kind of make it simpler, this is kind of what it looks like. So what they are a sales effectiveness platform where they provide basically ML as a service. So they're providing predictions as a service. And the 3 models are the ones that are on the right. Like one of them, I think, is what do people who have the same kinds of things on their cart buy? What are people with the same history buying? And so on and so forth. But the important thing is their clients are all different sorts. So they might have the same client base with people selling routers and people selling something else altogether. So what we wanted to do was we wanted to build a system where we could get the customer data that they have into DSS, provide the predictions back to the customer where we didn't really appear on the scene at all. So for them to make this automated product that looked cool without us ever being in the picture. So what were the technical sort of issues? We had to go from one to many products. So we must basically take one project in this design stage, and we have to turn it into many in the automation stage. we might have to ingest one type of data set while we're designing the model, and then it must be many because each of these customers has their own sort of product history, product catalog, and so on and so forth. And once it's done, we have to design it so that it runs as many different services because obviously each of their clients will have their own sort of API endpoint. And so this is basically how it's done in DSS. I won't bore you with the boring details, but what I'll show is what that looks like sort of in a sort of solutions architecture point of view. So basically, we have a design environment where we took one sort of main project and we had one data table. Then once that's copied over many times for some of their biggest clients, we can create these different projects that can kind of connect to their own data tables and kind of train the models now continuously and automatically. And once that's done, the automation environment also connects to the sort of real-time scoring environment where each of these clients can now access their own sort of predictive model. So, what made all of this possible? And I'm saving clearly the best for last. So DataIku, which is a data science platform for collaboration at scale. We were founded in Paris way into, like now, what, 5 years ago? Oh my God, it's 2018, isn't it? Yep. But we were founded then, and since then we've been making a steady journey to New York, to other offices in London. And pretty recently, we basically got our Series B funding to really kind of do our own thing at scale. And we've been doing that with, I'd say, a fair number of customers here in the US and also in Europe, and some in London. And these are just the names of the customers we work with. And sort of to kind of finish the story and go back to this idea about why data science in production with data scientists is hard and is hard to do at scale, I want to kind of end at what our sort of solution for that is. And what we believe is that we have tons of people in organizations who have data knowledge and data skills. Not all of them are data scientists, and that's all right. But usually what collaborative tools do, or at least seem to do, is provide a way for people at the same level to collaborate, whether it's the data analyst or whether it's data scientists who are working in code books collaboratively. But what we believe is that to be able to get data science done at scale and in production, we have to have people from different backgrounds. Well, that's just here we go. Different backgrounds with different skills. And let's be honest, like the data scientist there is not one person at one skill level. There's many different kinds of unicorns. And so it's to be able to have people with a whole host of skills collaborate together to do data science. Because we believe that vertical collaboration is what is sort of additive. That's what gets you the value. Whereas horizontal collaboration is mostly about sharing. So I'd encourage you to check us out if you want to find out more about our story, because we allow this collaboration to happen through visual, which is what a lot of what you saw earlier, but also code, which is pretty much built into the tool itself. And this is how those projects get done quickly, because it's a combination of that. It's the combination and the ability for different kinds of sort of persona to come together to build these data products quickly. And the way so data science gets done at scale quickly and it doesn't take so long is you make data science a team sport, where you just don't have data scientists. You have different kinds of persona working together to make it successful. Thank you for listening, and I've left hopefully enough questions, enough time for both questions as well as thank you very much.